One, we're starting out pretty simple and we're using stuff from the book. Not always will we be using the book. In fact, most of the time we won't. But I just want to introduce you to some concepts in kind of a simple, straightforward way. You have this area around the city of St. George, and you're going to observe this place and infer how geology affects the people who live here. Kind of like what you did in the first discussion. So I have a number of things to bring up. Um, Bear with me. This area has been vertically exaggerated 2 times to show the features better. In this area, you have a small amount of rain. It's pretty hot in the summer. The nearby mountains receive snow and torrential summer rains, which causes flooding. Then we have several small rivers that flow through the area as well. If I could point this out, you can kind of see it. There's also been recent volcanic activity. The cliffs here mark the location of an active fault, which could cause small and moderate sized earthquakes when there's movement on that fault. And then as well, warping of the rocks over time has trapped petroleum in the area. So we got a possible oil field right here, and then we got farms located next to the river. City of St. George is highlighted there. River, and then reservoir. Just bring that out a bit more. Farms. Okay. There's also mountains with steep slopes and drainages headed toward the city. And there's our fault. And there's our volcano. So this is a real place. We can look northwest towards the mountains, St. George being to the left of you. And around St. George, Utah, we have these pine-covered mountains in the distance. We didn't really see that in the previous image because it was limited, and rocky cliffs in the foreground. There's also this volcano. It's an eroded basaltic volcano east of St. George. And there's a cliff along the fault. We see a lot of erosion here. Those are called hurricane cliffs east of St. George, Utah. They're formed by displacement along the active hurricane fault. There's also what we call an anticline. It's kind of an A-shaped hill. We'll get into that later. If you were to go way under the surface here, because the structure is rounded like this, it can trap oil. And then here's a view of the farms along the river. All right, so that's kind of the landscape. And then I'll bring up the worksheet here, if I may. Here we go. All you have to do is in the white space below, you need to write 5 observations about the landscape. You don't just simply repeat the information from the textbook. Just write what you noticed. And then you can mark on the figure one location where the geologic processes would likely occur. So again, I wrote this in the lab, but you can edit the PDF if you have those capabilities on your computer, or you can print it off and write on top of it and then scan it or take a picture of it and upload it for credit. So make sure you just follow through on all those directions. This pretty simple as well. It's not like there's one right answer. I just want to get you thinking. I want you to propose one or more ways that each landscape feature or aspect might influence people. So do that in the space provided. Spend a little time on it. That part's pretty easy. Next, let me bring up the explanation for the second worksheet. There we go. Okay, so we left off just thinking about what evidence we might need to prove or disprove our models here. With the volcanic explosion, the rising mass of salt, or the meteoroid impact. You're going to be writing that to a degree in this lab. So looking here, the question is, what formed this upheaval dome? That's the structure that you see right there. It's a circular feature within flat-lying sedimentary rocks, and the rocks have been bent upward around the dome. Got these flat-lying sedimentary layers, circular feature, and then layers bent upward. So if you think about the principle where the oldest rocks are on the bottom and the youngest rocks are on the top, I want to see if that applies here or if there's any evidence they've been folded over themselves. You're going to look at this sequence and determine, you'll determine the sequence in which the layers formed. Looking at all these units, you're going to put into this worksheet whether or not the sequence that you see is in the correct order from top to bottom. And the last part of the worksheet, I'll bring it up too. We'll just be looking at these three possible explanations for the origin of the dome. You could have a rising mass of salt bowing up into the rocks. You could have a rising magma body that bowed up the rocks but did not reach the present level of exposure. Or you could have a meteoroid impact that struck the surface while the rocks were buried, causing rocks to sort of dome upward beneath the crater once the rocks are blasted out. And I'm going to ask you to draw kind of a simple sketch. So, with that, all right, this is your worksheet. And I can't really use my mouse on this monitor because it's too offset. It's going to look weird. So I will just describe it for you. But with these investigation sheets that I provide, first off, you're going to write at least 3 short observations about the landscape. You'll use the stratigraphic section in the PDF provided and the cross section from the investigation to determine the order in which these layers formed. Just tell me, is that sequence correct? In what order would you write the oldest to youngest? Write them in this space. And then this part is open to interpretation. You'll record 2 questions you might ask about how this landscape came to look like it does. With this, I noticed last semester people got a little confused. I want you to draw little cross-section sketches of, say, a dome warped by a rising mass of salt, a dome sort of influenced by rising magma, or a dome formed by a meteoroid impact. We have something similar in the book you could go off of. When we say what the prediction might be, you're going to say basically what you would predict to find in the field, say evidence of salt and how you would test that. Go out and drill into the rock perhaps to test that prediction. With magma, you'd be looking for igneous rocks. You'd have to have a way of getting at that information and observing it in the field. Same thing with meteoroids. So, and then just say if there's any additional information that you think could be needed to explain the origin of this upheaval dome. Again, this is our reference page. You can look at it, you need it, but you don't turn it in. Well, you know what? You probably do turn it in because it's all part of the same PDF. So with labs, I want it to be very clear that you can contact me at any time with questions. I'm very much used to that, and I want to make sure everybody does well. So let me know if there's anything you would like clarification on, okay?